today, and glad to be able to share this next hour together to think together critically about mathematics education and ways that we might continue to broaden participation in this field. We're excited today to be joined by Dr. Marta Civil. Dr. Civil today is joining us from the University of Arizona. I'd like to just share a little bit about her. Dr. Civil grew up in Barcelona, Spain, where she obtained her undergraduate degree in mathematics, and then she moved to the University of Illinois at Urbana-Champaign, originally to pursue her interests in logic, but discovered the field of mathematics education when she became a teaching assistant for a mathematics content course for prospective elementary teachers. She obtained her Ph.D. in mathematics education and moved to Tucson, Arizona, where she is currently professor of mathematics education at the University of Arizona. And her move to Tucson marked her professional career as she became involved right away in projects working with schools in primarily Mexican-American neighborhoods. She has over 25 years of experience engaging teachers, children, and families in mathematics, primarily in working class Latinx communities. Her work focuses on cultural, social, and language aspects in the teaching and learning of mathematics, linking in-school and out-of-school mathematics, and parental engagement in mathematics. So Dr. Civil, thank you so much for joining us. I'll turn it over to you.
Thank you so much, Paul, for this wonderful introduction. I don't know where you got the information. It was all right. I don't remember giving you that. I mean, very few people know that I mean, the whole thing about logic, that I wanted to study logic and then I switched. So we'll have to talk about that. What sources do you have? And thank you all for being here. So what I'm going to do is I'll be sharing my screen in a second. And hopefully, I mean, this is an informal, so, you know, feel free if, I mean, you know, it feels very formal that I have a PowerPoint, I'll be talking, but feel free to interrupt if you have questions. It won't be an interruption, it'll be a conversation. And I'll give some opportunities to use the chat and, you know, for people to give, you know, share their thinking. So let me start, or let me share first, because otherwise, okay, all right, okay. And hopefully you're seeing this slide and not the presenters mode. Okay, because I've seen everything happening. All right, so as I say, I'm going to talk about the idea of diversity as a resource towards students' participation in the mathematics classroom. And the first thing I like to do is if you could use the chat to basically tell me about, you know, who you are, and maybe share your thoughts on these two questions, both either what comes to mind when you hear the word diversity in the context of mathematics teaching and learning, and what does it mean to view the diversity as a resource? So I'll give you a few minutes to start, you know, and just put, you know, use the chat feature. And if you don't want to answer the questions, you just want to tell me who you are, that's fine too. Thank you, Mark, for starting, because usually when one starts, then we get. Okay. Daniel, Sharice. Matthew, Scott, Harlan. This is great. And I see quite a few of you are currently teaching, which is what I was expecting, but it's good to, middle school and high school. So I'm sure you have lots of experiences with diversity. You probably have much more to share than I have to share, but hopefully have something of interest for you. Oh, and we have someone from Arizona. All right. Eileen from Arizona with Corey. Okay. All right. Keep writing. I mean, it's not, so let's see. So this is a quote from Richard Barwell. Diversity tends to be presented as something to be accommodated rather than an intrinsic and valuable aspect of mathematics classroom life. So that's the message that I hope, we all focus on, that when we hear about diversity, quite often it's presented as a problem. It's like, oh, we have a teacher in a diverse classroom, or teachers work in a diverse classroom, and there is this sort of implicit message about it's going to be problematic, right? As opposed to, of course, seeing it as an intrinsic and valuable aspect of the mathematics and how we can take advantage of it. So the plan is for today is to explore cultural and linguistic diversity as a resource towards participation. I'll present a framework for participation, and then I'll provide you the opportunity to experience some of what I'm talking about through a task. All right, so a student comes to you and shows you this. How would you react? What do you think is going on? And feel free to, if you want to put something in the chat or. Of course, it's a little bit unfair, the question, because if you were a teacher, you would probably have, for this student, you will have more context. But I took that from an article by colleagues of mine in Barcelona. And when I first saw it, I have to say that I don't even know if I realized what was going on. I think that the article said actually, so up to today, Donato, I have to share that. Up to today, I actually had taken a picture, and the picture is professionally done. But the picture, it was a scan, it wasn't clear. So I actually did this yesterday or 2 days ago when I was preparing. So this is my handwriting. So that's a, and I'm glad you can read it because most people cannot read my handwriting. It is an algorithm. And any idea of what's going on? It is indeed an algorithm. And of course, if we were teaching this, and the student comes with a different way of doing an operation from what we've learned, hopefully we will be asking them, how are you thinking about it, instead of what some other teachers may have done, which is, but here's how we do it. So basically what this is subtraction. This is 314 minus 182. And the student, what he or she's, I don't know, what they say is they do 3 minus 1, 2, and then the student says something along the lines of, I haven't done that in a while, so that's why I had to cross the 2. And so kind of implying that maybe if when they were doing it more recently or whatever, maybe they will do 3 minus 1, and they will right away see that they were going to have to regroup for the 1 minus 8. And so maybe write directly the 1, and then 11 minus 8 is 3, and then 4 minus 2 is 2. Okay, so that's what it is. And so basically we already, so this is the way that an immigrant student, I believe from a country in the Northern Africa, but I'm not sure that the article specified if it was Morocco or Algeria, or that's how this student had been taught how to subtract in his home country. Okay, so this is the work that I've done with pre-service teachers. I will show them different algorithms. So here is one, subtraction from left to right. So, I'll show it to them. And then I ask the pre-service teachers, these are usually teachers who are going to be elementary or middle school, okay? I know that most of you are teaching middle and high school. At the end, if we get to it, because I have quite a few things, I do have an example from a middle school classroom that might resonate with you. But this is an algorithm. And so then the pre-service teacher wrote, from left to right, wouldn't kids get confused? If I show them from left to right, I would think that when you got to the real thing, and the emphasis on the real thing is mine, that they would get upset or would get confused. And this is a point that I want to make, that we tend to take for granted the ways that we were taught or that we do things without realizing that, as I'll say later again, mathematics is not culture free, in that students who've been schooled outside the US may bring different ways of doing things, and even if they've been schooled in the US, okay? So that there are many ways to do problems, but quite often with arithmetic, there is a tendency to think that everybody subtracts the same way, everybody divides the same way, everybody multiplies the same way. So here's another example. This is a very famous algorithm, where a very young kid, like typically you hear, we shouldn't, but you hear 3 minus 8, you cannot do that. We need to, and so the student obviously, knew negative numbers, and so 3 minus 8 is -5, 70 minus 50 is 20, and then 15. And this is what a pre-service teacher say. I do believe that you could eventually convince him that learning to carry is easier and leaves less room for error. Again, it's easier for you because that's how you learn it. And maybe working with negative numbers is not that easy, but it's not necessarily easier for the student who is subtracting this way. So how do we react to difference? There is this article that if you're not familiar with it, I recommend it. Mathematical notations and procedures of immigrant students. And so, they go over different algorithms, but most importantly, they go also over notations. And so, for example, in many countries, including the one I'm from, the 1 billion, which in 1 billion, it's 10 to the 9th in the US, for us is a million millions. So think about when we're talking about large numbers and debt and all that, what we might be understanding when we hear 1 billion, if we're thinking 1,000 millions versus a million millions. And then, of course, the comma or period, I still get confused, right? Because I've been in this country for more than half my life. So I know that the period is for the decimal and the comma. But when I go to Spain and I'm looking at a bank account or something, I need to think the other way around because I'm going to get really confused. So things like these that could create confusion if you have students or the parents with a different notational system. As I said, the differences in algorithms. So when pre-service teachers read this article that I just mentioned, the reactions in general were along the lines of, oh, I didn't know this, so this is interesting. But there was one in particular that caught my attention, which is, this is nice, but they need to learn to do things the US way. And so that's what I try to work, to address in my work with teachers. What do you mean by the US way? And so basically we want to build bridges to student success. So hopefully my work is about that. So we're going to look at participation now. And so for that, as I said, I have a framework to think about issues of participation with 4 components. The first one is the concept of status. What does it mean to be good at math? When we say, oh, the student is really good at math, the student is not so good at math. What do we base it on? How do we know? The second one is the nature of the task. Whose knowledge and experiences are represented when we give a task? The third one is the approaches to doing mathematics. Whose and what approaches are valued? Again, going back to the algorithm, the person who does a different way, are we going to value that? Or are we going to say, yeah, but you better do it this way? And then languages in the classroom, which languages and forms of communication get privilege? So let's look at the first one. Status, those of you who may have, maybe familiar with the complex instruction, you probably have then heard about status, but I have to say that this is not, when I was using the concept of status, I was not familiar with complex instruction at all. So for me, status, it's related to what they talk about, but it's basically the lay terms of, the lay understanding of status. And I was working with 5th graders And it was fascinating to see how aware they were about status. And in that particular class, and it's not unique to them, the popular children, and those, for example, were the children who were good at sports, had high status. And also the children who were in the gifted and talented program, they also had high status. Okay, that's not a surprise. In this 5th grade class, we had 29 students, 18 Mexican American, 1 of Central American origin, 5 white of European origin, 4 African American, 1 Native American. In GATE, we had 7 students, 4 of them white of European origin. Okay, so you can already start noticing some interesting things here. And the children were very aware. And this is the quote from, the first one is from a child in GATE, white of European origin, Rebecca. GATE tends to be upper class white people. I've noticed it's kind of a corrupt system. This is a 5th grader in GATE herself, very aware of what was going on. And now we get to hear Anthony, a Mexican American kid, not in GATE, very amazingly, with mathematics, it was amazing. If GATE is to make us more intelligent, how come I don't get to be in GATE so that I can get smart? I'm telling you, these are in 5th grade. So now think about it. You are teaching middle school and high school. You are getting the children who are the product of already from very young age, depending on which schools they've gone. And this labeling, this separation, this idea of what constitutes, being good, not being good at math, of course, I'm talking about. So again, what do you think your students would say about their awareness of how the education school system works or actually does not work? You might give it a try. You might actually try to find out what are the perceptions of what does it mean to be good at math. The nature of the task. So whose experiences are represented in the tasks we provide the students? Are we willing to work with different interpretations? What if the students bring their everyday knowledge into the mathematics classroom? Does the real world really matter in the mathematics classroom, and whose real world? So we're going to look at one example now. This is 8th grade task from the Mars Shell Center team from the Alan Schoenfeld and people at the Shell Center in Nottingham in England. And so this is a pretty standard problem. I mean, you have these hexagon tables. And Sarah, this is the story. Sarah, student, in the narrative, Sarah finds how many students can sit around a row of desks, complete Sarah's table. And so the table went till 7 desks, just put up to 5. So the students, will fill out the table. They will maybe draw the hexagons, whatever, they will do that. And then Sarah says that 47 students can sit around a row of 11 desks. Without drawing the desk, explain whether you agree or disagree with Sarah and why. Okay, so Sarah says that 47 students fit. And so the students had done some work, they had gone all the way to 7. And so Octavio, an 8th grader, did some calculations, used the information, and he noticed that for 11 desks, it would be 46 students. So since the question is saying, Sarah says that 47 students can sit around a row of 11 desks, and you have to say whether you agree or disagree, one would expect that Octavio would disagree, because for 11 desks, it's 46 students. Okay. So I'm going to play the sound. You cannot hear it very well, so I'm not really sure, but I just want, hopefully you'll hear it. And in any case, in the next slide, I also have what he says, okay? But I just want to play it because this is an, oops, sorry. This is a, okay, maybe not. Here it is. He's an emerging bilingual.
What did you put there?
Agree.
Okay. Why do you agree?
Because if I put 8 tables and it's 34, 311 is 46. Kids will be 46 in because it's only by 1 student.
Okay, so
why put it like one student right here.
Okay. So
what Octavio is saying is that, yeah, it's 46 for 11, but it's only a difference of one student. So I can put the student there. And I don't know if you can see the little dot in the corner. I can squeeze that 47th student in there. So therefore, I agree with Sarah that you could have 47 students sitting around a row of 11 desks. Basically, that's what he says. So again, now we have a student who knows the algebra, who knows how to fill out the table, or maybe not, I don't know about the algebra, the formula, but knows how to solve the problem, can reason. But the question is asking, can you feed 47 students or kids? Yes, you can. Just put them in a corner. Okay, so he is answering the problem, not in the mathematical way that one may be expected. Approaches to doing mathematics. So here's another one. A watermelon and 2 cantaloupes cost $4.65. 3 watermelons and 2 cantaloupes cost $10.15. How much does 1 watermelon cost? So of course you could solve it algebraically, setting up equations, or it could be solved by looking at the problem and reasoning, because you notice that there is a difference of 2 watermelons costing, the $10.15 minus $4.65. There's a watermelon and 2 cantaloupes, and 3 watermelons and 2 cantaloupes. Okay, so you really don't have to set up equations. You could just do it. And so that's what David did. David, a Preservis elementary teacher, he reasoned through, right? So he reasoned that the difference between the 2 situations is $5.50, which corresponds to 2 watermelons, and thus 1 watermelon costs $2.75, which is correct. But he's hesitant and he's checking his reasoning several times. And so I asked him, what's going on? And he says that the watermelon looked too expensive to him. Now, this was in the mid-80s. I don't know if a watermelon at $2.75 was too expensive or not. And I don't know that because I didn't care, right? I mean, we give a problem and we don't look, and I take full responsibility. Whatever, we just want them to. And maybe the watermelon was expensive, and I didn't think about it. David was looking at the problem from a realistic point of view. And then he said, actually, I probably should use algebra because I would come with proper numbers. The solution could be wrong. I'm not so confident. Now, had he used algebra, he would have come up with 275, but maybe he wouldn't have doubted the answer. So we have a double problem now, right? Because we want students to doubt if the answer doesn't make sense. But if they're using something that is like magic, algebra, then maybe they don't doubt it. So again, what are we producing? I gave the same problem to another Preservis teacher. She did the algebra, nothing, didn't question anything, and then told me, yeah, I just set it up, I just solved it. She solves it for both. So if they're asking for the watermelon, it didn't matter to her. She found the watermelon, the cantaloupe. It was just like a mechanic, you just do it. So who would I rather have as someone, as a citizen, to think about issues or whatever? David or the other student who was just going through the motions? So it's something, to think about. So again, over the years, I've noticed that students who are really trying to make sense of the problems and do bring their everyday experiences, like squeezing the kid in the 47th, in the corner, or the watermelon that might be too expensive. And those who, and so the difference between, the ones who bring the everyday experiences and those who don't and are very good at playing at the school game. What kind of students do we want to prepare? The ones who want to make sense of the problems, bring everyday experiences, or the ones who just, again, go through the motions and play the school game? How open are we to value approaches that may be very different from our own and from the ones that we teach? So this brings me to valorization of knowledge. It's been implicit in everything that I've said. Which algorithms we value? What do we value? And so we all bring our values, so it counts as mathematics, right? We are all guilty of that. We see a method and there's a method that we favor more than another. Some of it might be that we understand it better, And we saw this with the different algorithms. Now, parents, a lot of my work is with parents. mostly with mothers of Mexican origin, they also bring valorization of knowledge. All right, so now let's think about this, and I'd like you to think about how you learn, or perhaps how you were taught how to divide. So not so much how you might divide now, or if you teach division, how you might teach division now, but think about how you were taught. And if possible, I'm in presenter mode, but I think that we could do it. Yes. If anyone wants to volunteer, and let me try something before I say anything. I think we can do it. Right? Yeah. If anyone wants to go ahead and use the annotate thing and basically share how they were taught how to divide, that would be great. Because explaining it in chat may be a little bit trickier. Oh, all the participants cannot annotate. Oh, I see. So I see that Paul can annotate, but I guess Paul has a different, okay, I don't know, I don't control this. No, Carly was able to annotate something. Flor is annotating something, okay, so maybe. So this setup, I'm kind of curious now, I'll ask another question of the participants. If you could, in the participants, if you could indicate with a, I don't know what the options are here because I have too many screens open, but with a yes or thumbs up or whatever, how many of you in the participants, so I can see it in the participant list because I don't see you, agree or not agree, but were taught this way, the way that we see now being, yeah, exactly, the check mark. I couldn't see what the options were. That's what I was, oh, thumbs up, yeah. So how many, either one, thumbs up, checks. How many of you were taught the way that we see happening here, which is the 42 into 1224, and then 2 times 42 is 84, so minus 84. All right, I see many people who are not putting anything yet, which I'd be surprised that there aren't more people who were taught this way. But maybe I have a very unique group. Okay, Brandon, so when you say I learned this method, you mean the method that is being shown right now on the screen?
Correct.
Okay, yeah. So basically, I mean, it was a line and all that, but it was still, I mean, it was the same method. All right, and then we're going to, yeah, Flor is going to finish this. It's very hard to write and annotate. I learned that, I mean, unless you have the nice features that some people do, but I don't, so I struggle also. It's just the mouse. Okay, so am I to believe that all these people who didn't put a check mark learn a different way? Well, no, Flor probably learned this, well, maybe because Flor was doing it, but I see that Jose hasn't put anything, Corey, Kimberly, Christy, in the participants, you know, like the check mark. All right, so I'm going to have to erase this beautiful thing. I know you don't have the room to write it, but you're going to see it in the next slide. But I'm going to erase because if I don't erase, you won't, well, become a mess when I do the. So thank you for doing this. And now let's look at, oh, I need to get out of the annotate, otherwise it won't let me. Okay. So this is how I was taught, and people in Colombia and people in many countries, okay? So notice that we write it in mirror image or whatever, and we don't do the subtraction. We go directly, 2 times 2 is, so we will go, 2 times 2 is 4, 4 to 12 is 8, 2 times 4 is 8, 8 and 1 is 9, 9 to 12 is 3, bring down the 4, 9 times 2 is, 18 to 24 is 6, 9 times 4 is 36, and 2 38, so that's it. So that's how I was taught. That's how I still, well, both ways, but this is in Mexico. So Mexico is set up like in the US, but the subtraction is done in your head. And so I work a lot with parents from Mexico, and division is a big deal because they really don't quite understand in the generic term why their children will be learning this way, because they find this way inefficient as compared to this way. Okay, because in this way you have to do it in your head, right? And so basically, well, and then there is the method that now you see being taught in many schools, which is more like the scaffolding method, the repeated subtraction. Okay. All right. So going back to values, this is what a mother said about the US way, and US in quotes. When I looked at how he was dividing, referring to her son, he subtracted and subtracted, and that he wrote all the equation complete, I said, this teacher wants to make things complicated. No, son, not that way, this way. And he learned faster with this procedure, the Mexican way. I mean, I put the Mexican in quotes also. So that's a mother's reaction. And then in the same meeting, another mother said, I tried to do the same with my child with divisions, that he didn't write everything, but he says, no, mom, the teacher is going to think that I did it on the computer. You don't need to write the subtraction, son, I say. You only put what is left. No, my teacher is going to think that I did it on the computer. I have to do it like that. Okay, you think that, but I want to teach you how I learn. And I did teach him, but he still uses his method. And that way he feels safe that he's doing his homework as they told him to. The same thing with writing above what they borrow and crossing it out. I tell him, I remember our homework did not have to have any cross outs, whereas his does. And this is in reference to here, when you do the subtraction, so here you put the 84, like for example, in here, you would, I mean, we didn't do it, but I mean, I could cross this out and regroup. And this crossing out was not, for the mothers in Mexico, going to school in Mexico, that was not good because it looked not clean enough, not neat enough. And then of course, the put in the subtraction. But what is interesting to me about the quote is this, right? He feels safe that he's doing his homework, as they told him to. So it's this idea of the teachers have a certain expectation, and if it's not done this way, and when I share the two methods of division, the teachers, some teachers in this country will tell me, oh, but they are not showing all their work. What if they make a mistake? And I'm thinking, so many people in so many other countries have learned this way and that hasn't become an issue. Why is this an issue all of a sudden? So, again, valorization of knowledge. There's not that a method is better than the other, it's that we bring our values. So mathematics is not culture free. And so think about the richness in looking at these different algorithms, methods. We can welcome this diversity that does building bridges between the students' worlds and the school world. And this is what a teacher said. The Latino children, if their parents come from Mexico, then they probably did it a different way. They're looking at algorithms, they're going to be like, my dad does it this way, or my mom does it this way. And so they're bringing it another way. So this teacher was embracing the diversity, right? Or this is what a teacher said about a kid who was trying to share a method that his mom used for multiplication. And granted, the method wasn't working out. He didn't know it well, And so the teacher didn't know how to handle that. And so basically said, that's in mama's home, let's do it the way that we do it in the school. What message do we send when we say to students, this is the school way and this is the home way? You know, we create this rift, this separation. The last component of the framework is the languages and forms of communication. So much of my work is with bilingual or multilingual learners. And so in my case, it's about valuing languages as resources rather than obstacles. So that's why I put the emphasis on bilingual rather than referring to them as English learners. They are bilingual because the English learner puts the emphasis on what they lack, which will be the English perhaps. They're not, you know, they're not quite there maybe. But it's also about students whose home language is English, but may have patterns of interaction or use forms of English that are not what the school or the teacher is used to. And also, students of certain cultural backgrounds may find it difficult to engage in mathematical arguments if that involves challenging peers' ideas or the teachers. And so there's a very interesting work done by a colleague of mine in New Zealand with Indigenous students in New Zealand, where challenging the teachers in a discussion, a mathematical discussion, is kind of like challenging their elders, and that's not something that they, you know, they can engage. And so they had to work with them about what does it mean to engage in a mathematical discussion. So we have to be aware of these. So Arizona, like California, we've had our share of restrictive languages policies. We're a little bit better now in both places, but again, so what are the implications of restrictive language policies for the learning of mathematics? What are we missing by not providing access to multiple languages? What do we gain by having the students bring in the multiple resources, the languages, humor, their everyday experiences? So now comes where I'm going to put you to work more. So I don't know if any of you, well, okay, so we're going to take a trip to Catalonia, which is where I'm from. And we're going to work on a problem that is set in a cultural context, which is unique to this part of the world. And so in the next slide, you're going to see a problem that it's going to be written in Catalan. So I don't know if anyone in the audience knows Catalan. If you do, then you're in luck. If you don't, but you know Spanish or French, Portuguese, or even Italian, it might be also, you know. So here it goes. I'm going to let you read the problem, and then I'm going to ask you to do something in the chat. But so what I'd like you to do is in the chat, put your thoughts about what you think this problem is about. So we have common denominators, we have division, probability, ratios, fractions, area of rectangles, ratios, surface area, population or the number of people in a group, fractions. So at this point, I mean, there are several things that one could do. If we were in person, I've done this with teachers in person. And so, you know, they will be in groups and they will be working on this, and well, to be honest, they will not be making a lot of progress at this point yet. But they might be looking in Google for some of these things to see what it translates. You know, I've seen people do that. You know, or we could go into breakout rooms and do the same thing. But what I'm going to, okay, floor is getting, you know, number of people per floor level. Yes, some words I see that are familiar. How persons, pieces, yeah, okay. So I wonder, oh yeah, number of pieces, yeah, that's true, pieces, yeah, here. Okay, there is, for example, there is piña, and when piña, if you look for piña is pineapple, believe me, it has nothing to do with pineapples. But if you were going to do Google Translate, you might get a pineapple here. Doesn't work. Okay, so let's see if the next slide helps you a little bit more. Well, that's the one that we were working on. So now this is the same problem, okay? This is that we haven't done anything, but now I'm going to show you a picture. And I'm telling you, això és un castell. This is a castle. This is not a castle, because castell is castle. It's a human tower, okay? So castell translates as castle, but in this context is human tower. So that's what we're talking about. We're not quite there, but maybe now this helps you a little bit more or not, okay? But for the sake of time, one more hint. This is a 3 Castel 3 de 8. The one that we had, I think, was a 4 de 8, 4-8 in the problem, but this is 3 de 8. And it's because of this. There are 3 people in each of these floors, in each of these levels. The one that we're looking at in the problem is 4. Okay, now for a little amusement, if you haven't seen castells in action, you have to. I mean, just now. I'm not at all into castells, by the way, but there is a reason why I'm into the problem. All right, so now that I've had the, sorry. So first of all, the kids on the top are very, very young. It used to be only boys, and then several years ago they started allowing girls, and quite often now it's girls because girls are lighter than boys. And also several years ago it became mandatory for the kids in the upper levels to wear helmet. And they're very young, as you could probably appreciate. They're very, very young. And so this is the rest of the problem here, or the rest of the language that you would need to solve the problem. So it talks about Restrictive. La piña is the thing at the bottom, you know, just everybody who's kind of helping, you know, hold the tower together. El tronc is this. And that's where the 4 of 8, so in this particular case, it's a 4 because there are, you know, 4 people, and it's 8 because the way you count it is you don't count, and then it's second, third, fourth, fifth, sixth, seven, and eight. Okay, so that's a 4 of 8. And what else? And then you have the different, yeah, so it says, el pom de dalt, which is this thing here, has the 2 kids here, not so kids, but dosus, el aixecador, el enxanyeta. L'enxanyeta is the little kid that goes on top, okay? And basically what the problem is asking is the total number of fascias. Fascias is this, is the belt. So all that this problem, from the point of view of the math, what this problem is asking is, what is the total number? Okay, so in fact, let me show you, okay? Resolver el problema, número de fascias. At the trunk, here, they're going to be 4 by 4, so it's 16 people, so therefore 16 fascias. And then the pom de dalt, we have the 2 plus the 1 plus the 1, so that's 4 people. So total 20 belts, so 20, you know. So that's what the problem was asking. So the problem itself is not all that interesting from the point of view of the math. I mean, you know, in the sense. But why did I choose this problem? Okay, so quite often we focus on the language, and so we look at problems and we think about the linguistic demands. And this had lots of linguistic demands, because even for someone like me, first of all, Catalan is not my first language, it's Spanish. Second, I know very little about Castells. I learned, you know, I have a niece who got involved in Castells when she was younger, but so I didn't grow up with this tradition, even though that happens, you know, that's part of my cultural background. And the language is very technical. So this language of enxaneta, this is of them, this is not everyday language, right? So I chose it for that reason. But I also chose it because the context matters. So you might have the language, but this is a cultural context and a language context, right? And quite often we forget that we might be giving problems that the cultural context is not meaningful to the students that we're working with. So what I wanted you to do now is, let me go back to one, slide. I wanted you to, if you don't mind, sharing a little bit in the chat how you felt during the experience of trying to make sense of this problem. You can use the chat too. And also what I did, of course, rush, but you know, is what I'm sure you do if you work with students for whom English is not their home language, is the whole scaffolding, right? I mean, if you only give the words, that's not going to help them. But if you show a picture, if you show a video, if you point at things, if you know, it brings more meaning. Yes, exactly. With just the text, is like, you don't, you know, yeah. And then, as I say, if you know a Romance language, you have an advantage. But even knowing Spanish well, I mean, even for me, knowing Catalan and Spanish, if I didn't have the terms, if I didn't know what the terms were, I mean, and I had to know what the trunk meant, even if I understood trunk. If I don't know that trunk means from the second to, you know, right before there's dosus, I mean, all right, so this is what I said before. So basically, just, you know, to wrap it up, and I think that what I argue for is the need to know and understand more deeply our students' communities, and for basically changing some of the ways that we may go about doing things if needed, depending on how we, you know, what we've been doing. So one question that you may want to consider is for yourselves is, what do you know about your students, their families, their activities outside the school day? So here are some statements that I often hear when working with teachers in the communities I do my work. They might say, the problem is the language, they don't speak English. Well, actually, they speak more than one language. There are some cognitive advantages of bilingualism have been demonstrated. Parents don't care, education is not that important for them. I have yet to meet a parent who does not care about their children's education. Lack of motivation. Children are very engaged and motivated in their community. Many of the children that I work with they help with the home economy. They help with younger siblings. They're very engaged. They're very knowledgeable of what's going on in the community. And then lack of parental involvement. What is our view of involvement? If it's based only on the physical presence in the school, then that might be a problem, right? So these are just a few things to consider. We need to move away from deficit language and deficit views of non-dominant students and focus on the many strengths that they bring to school. So what do we do when things don't look like what we're used to? Students and their families do bring or know different approaches in mathematics. As teachers, what kind of mathematical knowledge and dispositions do we need to address, to address these different approaches? And also I argue that it's not just about knowing or finding out what mathematical knowledge students bring to school, but what to do with that knowledge. So it's not enough about saying, oh, this is very interesting, thanks for sharing, but how do we build on it? What do we do with it? How do we go beyond the, that's nice and validating, which is important. But so why is attention to diversity important? I think that has always been important, or should have been, but perhaps now even more, because maybe we teach differently. We use maybe more group work, and maybe years back we have more mathematical discussions. So what are the implications of an emphasis on discourse for the participation of all students? Who has a voice? Remember, status. How are different contributions viewed and valued? Bringing in everyday experiences when not appropriate. So I want to argue for a mathematics teaching and learning that values and promotes difference. But, and this is a quote from my wonderful colleague and mentor, Luis Moore, but I'm afraid that instead we often lean towards a pedagogy of control, a strategy of regimentation that responds well to the school's historical mission to erase or stifle diversity by creating uniformity as deemed necessary for national elite interest in unity. So this notion of trying to get everybody to think the same way or mold them, according to a certain, things that we have in mind. And why do I do this work? I like this quote. I've been using it a lot. I find it very powerful. When those who have power to name and to socially construct reality choose not to see you or hear you, whether you are dark-skinned or disabled female or speak with a different accent or dialect than theirs, when someone with the authority of a teacher, say, describes the world and you are not in it, there is a moment of psychic disequilibrium, as if you looked into a mirror and saw nothing. So I hope this presentation has given you some ideas on how to go about doing some of this work. For me, a place to start is getting to know the students' community through them and their parents. Being a learner as much as a teacher has been the most gratifying experience. If you're not familiar, as a place to start, I suggest that you take a look at the resources that Todos, the Mathematics for All, offers. Many of these are available, you just go to the Todos webpage and they're right there. And I also want to encourage you, if you have the time and you can do it, there's going to be so Todos every 2 years has a conference. This year is going to have to be virtual. And these are the dates. And if you want more information, you can go to the Todos webpage. Get that. And with that, I'm done. So,
thank you so much, Dr. Civil. I think we have time for a few questions. And if you would like to ask a question, let's try using the raise hand feature, which is available in the reactions of the bottom menu bar. And then that should shoot you to the top of the list here, and we can have a few questions. If you have a question or comment you'd like to add or ask Dr. Civil, we have a few minutes here, so we'll have a few questions. Okay. Yeah. We got.
My name is Austin.
Austin, there you go. Austin McKenzie, Austin.
So I'm wondering, because I've been hearing and seeing a lot of this accepting and working with diversity in mathematics and the way that we view what students bring to the classroom mathematically, both through culture and home life and different things like that. But do you think with these things, with this progression in this direction, do you see that there will be also a shift where we focus less on standardized based assessments? Because I teach third grade, and that's something I see where a lot of times we'll work with math, like with a growth mindset or bringing different strategies to the different table or and different things like that. And then we'll go into a trimester based assessment. And I feel like the data doesn't reflect the understanding. So just, I'm wondering, with where you are within the world of mathematics, do you see a shift away from assessing, or how do we assess where we allow differentiation in strategies?
Yeah, that's a very good question. So many years ago, I worked with a second grade teacher, so close to, and she did an amazing project around the concept of construction. So it was an integrated unit, and the mathematics was there. But I remember that she was sharing how she was very concerned that whether the students were going to be able to do, the assessments were not as strict, is not the word that I want to use, but we had fewer assessments. I mean, the standardized testing and assessment, whatever, is a phenomenon that has been going on for many years, but I'm talking about even before that. I mean, right? I mean, so we had a bit more freedom to do this work, but even having more freedom, the teacher was really anxious about, are my students going to do well in those kinds of testing? And the reality is that, as I said, the testing was not, we didn't have the same pressures, but really we saw so much growth in the kids over the year that she finally she let go of this tension, right? I mean, she says, no, I know that the kids are learning, but that doesn't answer the issue because you have the test that you have to give, right? And I don't know what we can do to change the testing. I really think that the standardized testings that we're using, I see it at the college level. I mean, I'm at the university and I see it in our entry-level colleges, that we really, I think, are the wrong way to go about it. And I don't know what we can do to change it. I'm hoping there's talk, but I'm not very optimistic that with the pandemic and all that this is the moment to bring about change. I think that teachers who do the kind of work that I'm advocating for, they have to play the game. And so they spend quite a bit of time letting their kids really grow mathematically, as you were saying, but devoting some time to basically saying, well, this is what the test is going to look like. This is what you need to kind of learn, is the test taking skills, sort of. It's a compromise, it's not ideal, but we cannot really run the risk of, I would want to believe that if the students are learning in a rich environment like they would, that they will do well in the test, but that's not necessarily the case because the tests are so alien in the way they're presented that they might not be able to do well. So I really at the point that we are, we almost have to reach a compromise, unless we bring out a little bit of we make more noise and we end up dismantling the testing, process. I don't know, maybe other people in the audience have other ideas about what we could do. It's a very good question, Austin, very hard to answer.
Thanks for that question, Austin. I think Dr. Civil, your comments today about asset perspectives and challenge that whole frame as well, to think about what children bring to and what they know and what the ways that they do mathematics, rather than sort of what they don't know. And oftentimes assessments seek to sort of find out kind of where they may be lacking. And I think this is a challenge to all of us, both for instruction, but also for assessment. And
Yeah.
But we are at the end of our time, so I think we're gonna stop here. I want to again thank everyone for joining us today. I want to thank Dr. Civil for challenging us to rethink what it means to know and do mathematics from a variety of different perspectives. And I hope that everyone is able to put into practice some of what we've heard today, and to continue to challenge ourselves and our colleagues to think about these ideas and these issues. So again, thank you so much, Dr. Civil. Thank you all for joining us today. I hope you all have a wonderful rest of this semester, a great rest of the week, and we will see you all again in the early fall. And Dr. Civil, as you go through the rest of your semester and maybe hopefully get some chances to travel soon, we wish you all the best, and thank you again.
Thank you all for being here. And I know it's late, it's getting to your dinner time, and what, we're on the same time zone, so it's the same time for me. But you've been working for the whole day, and it's a long day for you. So thank you so much for your attention and your questions and participation.
And Dr. Civil, there was a question about whether or not the slides would be available. Is that something that we might be able to share with participants following?
Yeah, sure. Yeah.
Okay.
Yeah, I'll send them to you. Yeah. Mm-hmm.
Thank you so much. And we'll make that available to everyone. Thank you so much, everyone. Have a great evening.
All right. Okay. Bye.